Morning, everybody. I am going to give you a lesson on graphing rational functions. And you can see it's one of the pre-filled in pieces of paper that ordinarily I would have made photocopies for you. So I will try to give you plenty of time to write everything down. I think my best advice is to try to listen to what I'm saying, and you may end up having to watch this twice, but just to kind of get the general idea of what is going on. A rational expression is just that, the x over the x minus 2. It turns into a rational function when you have the equal sign, otherwise known as a rational equation. I haven't written in so long, my hands feel funny. I've been calling it rational equation, but function is the same thing, as you know. So a rational function is an equation of the form f of x equals p of x over q of x. So you've got the ratio part of it. That's where that word rational comes in, ratio. So you have a division situation where p of x and q of x are polynomials, and I think you know this, but q of x cannot equal 0. So that's the first part of that. You've been seeing the word asymptote. I said it wrong. Asymptote a lot. And an asymptote is a dotted line that a graph approaches but it never touches. So an asymptote is a dotted line that a graph approaches. It comes really, really close to it, hugs the line, but it never ever touches it. Vertical asymptotes are in the form x equals, and horizontal are in the form y equals. I know you know that this is the graph of a vertical line, and this is the graph of a horizontal line. The graphs of rational functions have breaks in continuity. So oftentimes, they're not continuous. There's breaks in them, there's skips, there's jumps. Kind of like a piecewise function. I know you recall, let me see if I can find a quick other piece of paper here. If you had a graph like this, we've seen these. These are the step functions before we've done. These have breaks in continuity, as do piecewise functions, which I'm sure you remember. They could look anything like that, although more commonly they looked like something like this. So those all have breaks in continuity. So you've seen that kind of material before. So they have breaks in continuity, like piecewise functions. These, though, these breaks, they can appear as asymptotes or holes, which is called point discontinuity. So that's the first page. So we always have a parent graph when we're learning how to graph something new. And it's the one where no shifts have occurred. Nothing's happened, really. Just the general graph. F of x equals 1 over x, where x cannot equal 0. And really, you can graph this using general XY charts. You end up going back to these a lot. Remember, they're T charts from middle school. So when you plug each of these values in, I'm actually using decimals. And you know decimals are not my favorite thing to use. But I feel like since you're all at home, and I'm at home, we should use decimals. So when I plug x in, those are the values I get. And I'm going to try to graph these. So I have -4, -0.25, which is about there, -2, negative 0.5. I've got something like that going on. And then I notice that I know I can't plug 0 in, or I can't plug 0 in. When I plug positive 1 in, I'm going to head in this direction. So that's what I have. And something you might find helpful is either to go to Desmos.com. I'll write that down right here. Kind of mess around with it a little bit. Could be helpful. And another thing is this really doesn't tell us all that much. What happens as we get closer going this way? Like it looks like it's going to, I know the further I go this way, it's going to get very, very close to 0, but it's never going to hit it. What happens as I go this way? If I plug 1/2 in, negative 1/2. If I plug in negative 1/2, well, 1 divided by negative 1/2, it's actually negative 2. So what's going to happen with this is it's also going to hug that. And it's going to look something like this. Really funky looking. And the same is going to be true here. You do your best to graph these. Okay? Now what's happening is that as x approaches infinity, f of x, so as x approaches infinity, which is heading this way, f of x, its height, its y value, is going to approach 0. As x approaches negative infinity, the same is also true. F of x will also be approaching 0. And as x is approaching 0 coming from this side, this is approaching positive infinity. And as x is approaching 0 from the negative side, it's approaching negative infinity. This right here gives you a horizontal asymptote at y equals 0. This gives you a vertical asymptote at x equals 0. And lastly, and then I'm going to end the video and I'll start a new one, I'm going to tell you a little bit about holes. Point discontinuity. It's really hard to write neatly while I'm holding my phone. Point discontinuity. Holes occur at x equals r when x minus r is a common factor of p of x and q of x. So just write that down or think about that. Okay? And I am going to start the next video soon.